This is CPM Precalculus Chapter 1, number 137. Given the points -2, -6, and -4, 2, Part A we're asked to find the length determined by the points. In Part B we're asked to write the equation of the line through the points in any form. So let's do Part A first, because we know the length determined by the points is just the distance between them. So we can use the distance formula. D is equal to, we know it's equal to our delta y squared plus our delta x squared. And delta y is just the change in y. And delta x is just the change in x. And we square root that. So this becomes looking at, well, what is 0.1 and which one's 0.2? Well, it doesn't really matter. So if this is 0.1, then this is going to be our x value and our y value from 0.1. So it's going to be x1, y1. And if this is point number 2, then this is going to be our x value from 0.2 and our y value from 0.2. Okay, so let's plug these in. So y2 minus y1, well, y2 is 2 and y1 is -6. So it's going to be 2 minus -6 squared plus x2 minus x1, -4 minus -2 squared, and don't forget the square root on the outside. Okay, so let's just simplify this because this is the distance. 2 minus -6, well, minus a negative we know is going to be canceled out and become positive. So 2 plus 6 is 8. 8 squared, 8 times 8 is 64, right? Plus, over here we have -2, and again we have a minus a negative, so these cancel out. -4 plus +2 is going to be -2. -2 squared is -2 times -2 is +4, and we still square root that. Okay, and then finally we just combine these and we get that's equal to the square root of 68. Okay, and we could say that 68, square root of 68 units. If we want to approximate it, we can put into our calculator. We just plug in square root of 68, and we could say that it is approximately, and let's round to 2 decimal places, so that 4 rounds up because the digit right next to it is 5 or more. So 6 is 5 or more, so that's going to be 8.25. So this is approximately 8.25 units. Okay, so that we could say either one for Part A. So Part B, we're asked to write the equation of the line through the points in any form. So in any form, well, we need either our forms are y minus y1, our point slope form is equal to m times x minus x1, or we know y equals to mx plus b, which is our slope intercept form. So we can write in any form, so we could do it in either one of these. Well, we're just given 2 points, right? We're given point 1 here and point 2 here. Well, again, it doesn't matter which one's 1 and 2, but we labeled them. So all we need to find out is the slope, and then we can plug in the slope and one of these points, it doesn't matter which one, and we'll get the equation of the line. So our slope, again, is equal to rise over run, and that's equal to our change in y divided by our change in x. We know it's equal to y2 minus y1 divided by x2 minus x1. So let's plug in these values. y2 is 2. y1 is -6. Divided by x2 is -4. x1 is -2. Okay, so this becomes adding because there's 2 negatives. This one 2. So it's 8 divided by -2. If we just simplify that, it's going to be -4. Okay, so our slope is -4, and we can now have, using our slope and any one of the points right here, we get y minus y1 Again, I want to use this one. I could use this point too, it doesn't matter. Equals to our slope times x minus x1, which is negative 2. So let's just, minus the negative is positive, so let's just simplify this a little bit. Minus the negative is positive or plus, and this is the equation of the line in point slope form. Okay, I could go ahead and simplify this and solve for y and get slope intercept form, but I'm going to just be done, and this is the form I'm choosing. So this ends CPM Precalculus Chapter 1, number 137.